Hi, welcome back to my channel, and for today's video, we will be talking about the trigonometry series, and this topic will be trigonometric functions given that you have length of sides of a right acute triangle. So for those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. And for those who have been here for the longest time, thank you so much for your undying support. So we will continue with our educational series for these YouTube videos. So we will start by this figure. So if you suppose that you have this location of points here, so let's say you have x and y here. So this is the ordered pair, and then this is actually the line passing from the origin to this point here. So that means the line that is created by connecting two points form an angle with respect to the x-axis. Okay, so the goal here is to determine the corresponding value of trigonometric functions with this angle. We have to make sure that in order for us to identify such value of trigonometric functions, we will have to create a triangle here. So in order for us to do that, we will have to project a line perpendicular to the x-axis. So this means to say that this line here that is perpendicular to the corresponding x-axis will form 90 degrees. And always remember that in the basic geometry, back when we took that a few years ago in high school, we're actually talking about the Euclidean geometry. The sum of the measures of the angles of a triangle is always equal to 108. This is different from the one I posted before in my Facebook page that the sum of the measure of the angles of a triangle is always less than pi. That's kind of different because the one that I was referring to is actually a hyperbolic geometry. Here in Euclidean geometry, we have the definition that the sum of the measures of the angles of a triangle is always equal to 180. So since this is a right angle, this means to say that this one here is 90 degrees. And so the sum of the measure of this one is always equal to 90 degrees as well. So in this case, we will introduce a definition here. So suppose that this angle here is A, this one here is B. So in this case, we will have to assume that this hypotenuse here is our R. Okay, and the side opposite to the angle A, let's denote that by A. And the one that is opposite to the angle B is B. Okay, so we will introduce a definition here. We have the sine and the cosine. So when we talk about the sine of A and the cosine of A, that's definitely the side opposite to a specific angle. So that in this case, we talk about the angle A. So that's the side opposite to A, which is equal to A. And then that's the hypotenuse over R. So that's the definition of the sine. Now, for the cosine, this is the one that is adjacent to a given angle. So in this case, what is adjacent to A is B. And then that's over the hypotenuse. Okay, so if you want to take a look into that, remember that you have an angle B as well. In this case, the angle B, the one that is adjacent to B is A. So therefore, this is the same as the cosine of B. And this one is the sine of B. Okay, so the sine and the cosine are two of the 6 trigonometric functions that we will be discussing today. So we will be defining the other 4. The other 4, however, is, let's start first with the tangent. The tangent of A is actually defined to be the sine of A over the cosine of B. So that means to say that if you have the sine of A over the cosine of A, so that's the same as A over R all over B over R. So canceling the R, you get A over B. So in other words, the tangent of A is actually defined to be the side opposite to the corresponding angle A over the side adjacent to A. So the other three trigonometric functions are actually related to the first three here. So we define the secant of A. So that means if you have, this is spelled as this one, but it's pronounced as secant. So that's the secant of A is actually the reciprocal of the cosine of A. So in other words, the cosine of A is equal to 1 over the secant of A. And then the sine of A is equivalent to 1 over cosecant of A. And tangent is equal to 1 over cotangent of A. So these are the 6 trigonometric functions here. That's it. So we will consider an example here. You have the length of the side opposite to angle A is 7. The length of the side adjacent to angle A is 24. Find the value of 6 trigonometric functions. So we will illustrate that first so that we will be able to picture that out. So you have a triangle here, and let's assume that this triangle is acute triangle. So you have this one here, and let's say this is your A. So the side opposite to angle A is 7, and the side adjacent to angle A is 24. Although we don't really have to draw this one here because we're actually given already with a certain information, and that certain information is enough for us to solve. The purpose of this is that since we assume in this video that we are actually solving for a acute right triangle, then we will have to identify first the value of the hypotenuse because we need that information to fill out and to solve the other trigonometric functions. So observe that this is a right triangle, acute right triangle. So we can use the Pythagorean theorem to solve for the hypotenuse. Let's say this is your A, this is your B, and this is your C. Then to solve for the hypotenuse, we will have this one here. That's Pythagorean theorem, and you can solve it on your own using your own calculator. We can get the value of the hypotenuse to be 25. So to solve for the 6 trigonometric functions, we will use the definitions presented earlier. So let's start with sine of A. So sine of A is opposite over hypotenuse, so we have 7 over 25. Cosine of A, that's adjacent over hypotenuse, so we have 24 over 25. And so the tangent of A, that's opposite over adjacent, so we have 7 over 24. And then let's take all the reciprocal of these to get the other 3. So you have, and that's 25 over 7. And the secant of A, that's 25 over 24. And so cotangent of A, that's 24 over 7. Okay, now observe that if we label this one here by angle B, we can say that the sine of A is actually the cosine of B, and then the cosine of A is actually the sine of B, the secant of B, and this is the cosecant of B. This one here is the tangent of B, and this one here is the cotangent of B. And also the fact that A and B here are complementary angles because the sum of A and B forms 90 degrees. So AB here are complementary angles. So they form cofunctions with each other. We will define a formula for that. So given that you have an angle A here, so the sine of A is actually the cosine of 90 degrees minus A. If you take a look into the previous one, that's the sine of A is actually the cosine of B, and that A and B forms 90 degrees when you add them up. So that's the implication there. And then you also have the cosine of A, that's equal to the sine of 90 degrees minus A. So that means whatever this angle here. Similar thing goes with tangent of A, that's equal to cotangent of 90 degrees minus A, and so on with the other 3. So let's say, for example, if you have cosine of 52 degrees, that's equivalent to sine of 90 degrees minus 52. So in this case, that's gonna be 38 degrees. So okay, so let's consider an example here. Find the value of data satisfying each of the following. Assume that all angles involved are positive angles. They are positive acute angles. So let's try number 1. So you have the cosine of theta plus 4 degree is equal to sine of 3 theta plus 2 degrees. So how do we solve on that? So remember that using the formula, you have cosine of A that's equal to sine of 90 minus A. This simply tells us that this one here and this one here should be equal to 90 degrees. So you have theta plus 4 degrees plus 3 theta plus 2, that's equal to 90. And so you have 4 theta plus 6 equals 90. And so this is equal to 4 theta equals 84. And so this is equivalent to 21 degrees. That's it. Okay, so let's try number 2. So this also follows. So you have, that's 90. So this becomes 0. And so you have 3 theta, that's 90. So your theta is 30 degrees. Okay, so I hope you learned a lot today. So we will be discussing moving forward with a lot of topics in trigonometry. So thank you so much for watching. If you have any questions or clarifications, you can comment down there so that I would know and we can discuss on that. I'm really sorry if sometimes I might be busy, so I wouldn't be able to give you a reply for all your comments right away. But rest assured that by the time that I'll be able to see your comments, I'll be more than glad to provide you a lot of explanations if you have questions. So that's all for now. Thank you so much for watching. Have a great day.